This is part 2 in a series of videos in which I am restoring this machine. If you don't recognise it, it's a teletype model 33 and it's commonly referred to as an ASR33, but the ASR depends on the mode that it's running. As you can see, I've removed the casework. That's currently being cleaned, so I've got some work to do cleaning that up. I've removed the top cover off the keyboard. In this video, what I'm going to be doing is stripping the machine down into its major sub-assemblies, and then in the upcoming videos I'll go through each of those in turn, go through them, overhaul, service, repair them, whatever's required to get them fully functional again. I've got no idea what state this is in from the operational point of view. I have found certain things that I know for certain aren't working. It definitely needs a very good clean and service. Some things move but very sluggishly, so that is moving, but the rest are pretty much frozen, so a lot of work to do on that. And just to give you a kind of general lie of the land, if you're not familiar with these, what we have in here is actually a multi-part machine. If you saw the series I posted on the Creed teletype, it might make it easier to explain what we're looking at here. But essentially these were early communications systems, and they're interesting to me because firstly they're very interesting mechanically, but also they were the forerunner to modern computing systems, and really the development of things like these teletypes are what kind of guided the way to develop computer systems. The creation of these machines allowed the implementation of serial to parallel data, communication of data, the definition of certain types of data, and ultimately they progressed into computers. So these are quite fascinating from a historical point of view, but they're also very interesting from the electromechanical point of view if you are interested in this sort of thing. And also of course very interesting if you're just into vintage computing, because once you have these running you can use them very like a dumb terminal to do all sorts of things. But also in the case of a machine like this, we can produce punch paper tape, and we can also read punch paper tape. So what we've got here is on the right hand side, this whole block is the electrical control and signal distribution pack. This will all come out in one piece. Everything's pretty much just plugged into it, so all these big white connectors. They're normally all numbered so you can tell where they come from, but the ones that are fitted will generally depend on the options fitted to the machine and how the machine's configured. So we have this device. We've then got the what appears to be a keyboard at the front. This is really more accurately referred to as a transmitter. It turns values you set with the keys into a form of serial data, and that can either be fed directly out of the machine, or it can be fed to the central, the biggest part of the machine, which is the receiver or the printer, and it can also optionally be sent through to the paper tape punch. So the data you create with the keyboard is sent out various places depending on how the machine's configured and what mode it's running in. This functionality is to a certain extent duplicated by the paper tape reader, so that could do a very similar task to the keys in that it could take data, but instead of from keys it took the data from the punch paper tape that was passing through it, and that data could go through to the receiver or the printer, and then ultimately back through to the punch tape, or it could go straight out of the machine to whatever it's connected to. And of course at the back you have the drive mechanics, and although they're mostly attached to the printer, they are required to drive much of the machine. So they're the major blocks that we have. So 5 major blocks. We'll take those out in turn and set them on the bench. Have a very brief look at them in this video, but I won't start tearing them down. We'll do that separately. If you've watched my restoration techniques previously, then you'll know that I don't turn them on, I take them apart, but then ultimately I put them back together and get them working. So that's the plan. I've had a very quick look over this. I haven't really looked at it in much detail, and a surprising amount of it does seem to be functional. Things like the print head that normally needs a lot of work, it will still need stripping down and cleaning, but even things like the tape advance are actually working, so you can see that it's all doing what it's supposed to, but certain parts have seized up. So we'll get started stripping this down. Firstly, you can see the tape's not even on here properly, so I'm not quite sure when this was last used. But the first thing we'll do is take out the tape, get that out of the way. I'll probably need to replace this anyway, so we'll just get it out of the way, and that way we don't get covered in ink if there is still any ink left on this. So standard tape, it's only been used one way up. Normally what you do is you use it one way up and you can turn it over, and this has only been used one way up, so it might be okay, but I will most likely just replace that with a new one. Okay, things like this pad will need replacing. This one's rock hard, and other parts may well need adjusting, but it does seem to be in quite good condition. Belt's very slack, so that might need adjusting. But what we'll do to start with is get the electronics pack removed, and normally I start with this because everything else is plugged into it anyway, and certain cables pass underneath this assembly, so it's just easier to take this out first. So I'll spin the machine round so we can access it more easily, and then we'll set to work getting this machine dismantled. Okay, so step one is to unplug all the connectors from this pack, and then we should be able to actually remove it entirely from the chassis. So we'll get all the cables unclipped from the chassis first. Incidentally, these chassis are extremely clever. They're a bit flimsy and flexible when they're not attached to the base of the machine. I do have the base, but we'll look at that in a separate video. But it's actually a two-part chassis. It's two aluminium pressings, quite thin, sandwiched together. And as with any double-skinned assembly, it becomes quite stiff when you have the two assemblies together. But it also allows the inner skin to have a different shape from the outer skin, so certain things seem to disappear through the chassis, but there's no sign on the outside of any holes. So it is quite clever, and we'll look at that more closely later on. But for now, we'll get all these connectors unplugged. You need to be fairly careful with some of these. The PCBs can be a bit delicate, so be fairly careful when unplugging these. So that's the first one. And now we have these connectors. I'll just lower the camera slightly, you can see these more clearly. Okay, now I have taken reference photos of all this, although these connectors are all numbered. So the numbering sequence is 1, 2, 3, 4, 5, 6, 7, 8, and then there's a connector block at the bottom. But the plugs themselves are numbered. We can leave this one in, it's just a configuration jumper, but we need to unplug the rest because they connect to different parts of the machine. And I just need to remove a few cable ties. Now unfortunately some of these wires you do need to cut. You can see there's a join in this one, and separate these wires back here. So we'll start by doing that. I'm going to desolder these. I don't want to shorten the wires any more than I have to, so I'll do that off camera. All I'm going to do is desolder these three connections so that I can get the this flying lead out of the way. Okay, that's those wires disconnected. Incidentally, if you're not familiar with working on these, then take plenty of reference photographs and notes. the wires coming from the electronics pack don't always connect to the same colour wires on the rest of the machine. So for example, the red wire wasn't connected to the bottom red wire, so don't just assume that similar coloured wires are always connected together. Quite often they're not. We'll get that out of the way. So what we can do now is spin the machine back round and start unbolting the electronics pack. Now the wires at the back are very tight, and it's a real pain working on it if you do get a wiring fault, but we should now be able to get this whole assembly out of the way, and once we've done that, it greatly simplifies working on the machine because we don't have all these wires and this clutter at this end of the machine. So to start with, we need to remove this screw at the front of the chassis. So in theory you don't need to take it right out, but it is easier if you do that. And what you can do then is you can sort of work your way along. You can see, if you try and gently lift it up, you can see where it's held in place. So we've got the screw at the front, and there are two more along the side here. So quite often they're completely obscured with dirt and debris. These are quite nice and clean, so quite visible. And we've got another one back here. I'll just retrieve those. Okay, so that's those two removed, and you can see now that the whole chassis is starting to move. So if we now spin it back round so we can see the back end of it, you'll see that at the back we're held in place with a couple of screws that hold the back of the machine down to the base. So we now need to take those screws out, and once we've done that we should be able to lift this entire machine out. Now one of them is very difficult to actually see. Probably can't see what I'm doing here, but there's a screw right down here. It's actually hidden on this one behind this tab. And if you take this screw out, we should be able to raise the chassis up. So you can see now this is kind of nice and loose. And what we have to do now is untangle this mass of wires, separate it from this huge coil, and then I should be able to lift this out. So I'll do that off camera. The camera's actually in the way, I'm sort of reaching around it. But all I'm going to do is lift this out, and then I'll lay it alongside and you can have a look at it and see where we've got to. Okay, we now have the electronics pack completely removed from the machine. The three wires I disconnected, now we know where they're all going. These were just completely tangled up, so I can tidy all this up when I reassemble it. Two of them I can permanently reconnect, so unless I need the connections to be different going to the ASR33, which is what these are, then I can permanently reconnect these and just I'll put a connector on the loose one. But that will make future working on this machine a lot more straightforward. But as I said, I'll need to shorten the external cables anyway, so I will need to shorten all these, and it's far easier shortening it from this end than the other end because the other ends have the D-type connectors on them. Okay, so I'll get this out of the way and then we can move on to the next step of disassembly. Okay, so that's out of the way. The next thing I want to take out is the tape reader, and that's on the other end of this particular cable. But before we can get this out of the way, we need to disconnect this from the machine. So we'll leave the clip intact. It's easier to get the entire clip out of the way, and then just disconnect these. And then once that's done, we should be able to remove the entire reader. So we'll just unclip the cable from the chassis clips. Okay, and we'll spin the machine round so we can see the reader. So this is of course the reader. As I said earlier, I have already removed the screws from it, so it's loose. But I need now to unclip it from the remaining chassis clips that hold the cable in place. So we'll just get those removed. And what I should be able to do now is lift the entire reader out of the chassis. Okay, This is the blanking plate that sits behind the reader, so that will need to be cleaned and polished. But this is the reader out of the way, and so as I say, I'm not going to go over this in this video. We'll do these all in separate videos. We'll do one video for each major sub-assembly. I'll just get this out of the way and then we will remove the punch. Okay, so the next thing I want to take out is the punch. Now, one of the fascinating things on working with machines like this is as you go from machines such as the Creed machine that we worked on previously through machines like this, through onto intermediate and the modern computers, is you can really see the evolution in engineering. So for example, this is kind of halfway between the total mechanical Creed machine and the electronic machines that we're more familiar with these days. And what I mean by that is, if we look at the punch and the way it connects to the rest of the machine, it is the mechanical equivalent of a plug and play device in a Windows machine, in that it's very nicely integrated and yet it's extremely easy to remove. The linkages are designed so that they will very easily disconnect, and you can take this off and refit it in just a few seconds. Whereas when you look at the electrical engineering in this machine, you can kind of almost see that the engineers were really mechanical engineers that had to tolerate some electrical design within this machine. Whereas when you get to something like a PDP machine, it's almost the other way around, where the electronics seems to have taken precedence over the design of the mechanics. And you can kind of see that transition on a machine like this, where, as I say, it's pretty much a plug and play setup for the punch. It is an option for this machine, so they made it very easy to fit, but it also means it's very easy to remove and put back in. There's no electrical connections to it at all. Power comes through a rocking linkage at the back, and then the control signals come through a series of extensions from the selector rods on the printer. So we'll get the screws removed and then we should be able to take this punch out fairly easily. So 3 screws, we've got one here, and then there's one down here, then the whole thing should come out. So we'll just support it while we take the screws out. And as you can see, that comes out in one piece extremely easily, and it's as easy as a fit. You just need to make sure that all the selector rods engage with the forks on the end of the printer rods, and then just reconnect the drive linkage. So I'll get this out of the way and we'll move on to removing the keyboard. Okay, so the keyboard is also fairly easy to remove, at least now that we have the electronics pack out of the way. And this is one of the reasons why I prefer to remove the electronics pack first, because the control cable for the keyboard runs underneath the pack. But now it's out of the way, we can just gently prise up these securing tabs, and then the control cable will just lift out. Now the cable's freed off, what we can do is remove the electrical connection, and then we've also got a mechanical connection. There's kind of what's called an H-link that sits between the keyboard and the rest of the mechanism. I'll move the camera and hopefully you can see it, but I'm not sure how much you'll be able to see once I start trying to remove it, because my hands will be in the way, but we'll see what we can do. Okay, now I don't know if you can see this or not, but this is the linkage we need to take out. This kind of X or H shaped linkage. There is a slot in it that's there specifically to allow us to take it out, and the linkage is spring loaded, so what we should be able to do is push it all one way, and then if we tilt the screwdriver back, it should just lift up and we should be able to pop it up and out of the machine. So this will effectively disconnect the keyboard from the actual mechanism, and then we can just pull it back, hopefully the other way. Just a bit stuck there, but okay, that's a little bit tight, but it should come out. Okay, so that's the linkage, and now that's disconnected, we are effectively disconnected. There is a rocker lever at the bottom, but that's not physically attached, it's just pushed by the keyboard mechanism. So if we take the two screws out that hold this in place, we should be able to take the entire keyboard out in one piece. Okay, I'll move the camera back so you can see more clearly what I'm doing. So the keyboard is now secured with just two screws. There are two forks or prongs at the front that go into some recesses on the chassis, but there are only two screws that hold it in place, and I should be able to get those fairly easily. And then there should be another one, it's kind of buried underneath all the dirt and debris, but I think that's it. The keyboard should now slide back slightly and lift out. And there we go. So that's the keyboard out of the way. So again, we'll look at this more closely in a future video. This will need quite a lot of work, I suspect. In order to keep the key actions fairly light, the spring tensions on these tend to be fairly low, and that means they're very susceptible to anything at all, any contaminants stopping them working. So we'll look at this in a future video. For now, I'll just get it out of the way. Okay, that's the keyboard out of the way. This is the plunger I was talking about, but it's not directly connected to the keyboard, so as long as we don't damage that, then it is easy to refit. It's just a pain getting the H-link back in, because we need to compress the spring and locate this, but it's not too difficult. It's just a bit of a fiddle getting it down there. So the next thing is to get the printer out. First thing is check to make sure that no cables are trapped or go through any of the tabs on the chassis, and if we're sure that there's nothing securing it, in theory it should just lift out. It should be on rubber mounts, it should just lift straight off the chassis. Get this guard out of the way first. It's just a plastic guard. I should now be able to lift this out. It can be sometimes a bit stuck. This one's a bit tight. There we go. And as you can see, we can now lift it out. I'll put this to one side and we'll look at the chassis. Okay, so that's the printer removed from the chassis. Don't know if that's a serial number or not. 186648, serial number or part number. As you can see, there's lots of bits of swarf in here that I mentioned previously. But the next step is to completely clean this. I'll need to get this foam out of here. I think it's there just to catch oil, but it degrades. It's almost completely turned to mush, and I'll get that out of the way. But because it captures oil, you can see it really nicely preserves the chassis. Okay, I think the mounts might need changing. They are rock hard. But the chassis seems to be in exceptionally good condition. What I'll do next, I'll do this off camera, but I will show you the results in the next video. I'll give this a really good clean, and I'm going to just try fitting it to the base just to make sure that, the stand, just to make sure that it's all square and it fits as it should, not distorted or bent. Doesn't look bent, I can't see any dents in it, so again, quite nice that it's in such good condition, and it should make the basis for quite a nice restoration of this machine. But a lot of work to do, and we'll go over each major section that we've just removed in the upcoming videos. Comments welcome. If anything you want to see in particular with regard to this restoration, then please leave a comment.